Welcome to the second lecture of Thinking About Data. I think I'm going to make this fairly short, but let me get going and see, I have ways of making things longer than they need to be. I really do think it'll pan out pretty short. In part because I'm going to go ahead and rely a little bit on the idea of some of the background might be carried by my Chapter 7 lecture in my textbook, which likely goes along with whatever I'm assigning for complementary to what's going on right now in the class. So let's start from why we need to be thinking about data scientifically. So in the last lecture, I went over the idea about why data analytics in terms of human perception, and now I'm saying, well, we need to think like scientists when we're doing this. And what does this mean? What happened at the scientific revolution that changed things? And basically, what happened at the scientific revolution was the idea was the formalization of measurement error, and consideration of it as a factor in what we observe. Maybe that's an incomplete summary of what happened at the scientific revolution. 200, 300, 400 years ago. This long period brought us out of the Dark Ages, the Renaissance, that time frame in which we started to see a lot of advances in scientific reasoning, and then scientific discoveries and invention. Well, I say measurement error, and the idea is, okay, we're trying to figure out what's real around us, and because if we can figure out what's real around us, then we can better interact with the world and use it to our advantage, and to the prolonging of the species, and to the enhancement of the happiness of the species as we are prolonged, as we live. And so we're trying to understand the world around us. Well, we have a variety of observations we can make, a variety of dimensions on which we can be observing that world. Let's just take the idea of the five senses. And that's one of the ways in which we can observe the world around us. And then as we stack on top of each other the observations within the five senses and our existing hardware in our brain, we can start to build expectations of what things will look like and what they'll feel like and what they'll sound like that go along with that. And we do that individually ourselves. So we have very few instincts when we're born, but through this idea of interacting with the world and observing, we eventually accumulate a lot of knowledge from our babyhood on through our adolescence into adulthood. We'll continue learning. I'm not saying we don't continue learning, but the most radical developments are when you go from being a helpless baby who can basically only poop and eat to becoming a child who can move around and discuss things and speak and read eventually, and onward to being an adult where you should be capable of doing most of the advanced things that humans can do at that time, whatever time in history you're living. So, all right, let me get back to the idea. So we have this fundamental idea is we have this knowledge accumulation device inside of us, this ability to accumulate observations and reason them out into rules about the world around us, and that's great. That's great for individuals. But if we're going to pool the knowledge of the world around us, then we have to understand that not everybody's sight and vision, same thing, sight and hearing and taste and smell and touch are the same. There's five senses. They're not all going to be the same, and not everyone is going to take away the same beliefs or observations from each event. Some people are going to come away with an emotion-filled reaction to a certain event that makes them think the opposite of the next person the person sitting next to them. So that idea is the idea of measurement error. The idea that we have a difference, and error we're just talking about a difference between these two people sitting next to each other from how they react, how they interpret, what they learn about the world around them from a particular observation or event. And there's a difference. Okay, they both are using the five senses and whatever reasoning mechanisms they have inborn, and the differences could either be from their accumulated knowledge up to this point. It could be from differences in their actual mechanics. Perhaps they see things different, like they literally, one has keener eyesight, or one is focusing her attention one place, another person another place. Let's say we're sitting together at a football game or something, and we're learning about what this team is like. And so one person takes away the idea, well, I didn't really like the team because their passing was really bad. The other person says, well, actually, I think this team has a lot of potential because I saw a good, solid run game, and if they get the play action going, they'll be okay. You know, what two different things, two different observations going two different directions, and maybe this is a mundane example, but I think the mundane examples help us a lot, and they can be extrapolated to more pressing things. But the idea is we have an error, we have a difference between those two people. One person says, bad football team. The other person says, good football team. They both use their visual senses and probably their hearing senses as well, so they could hear the announcer as they were gathering information about this game, how it went, and derived larger lessons from that, so they can make better future decisions. Let's say they were deciding whether or not to watch a game. Well, that game's not going to be very interesting, the one person might say, because I don't think that team's very good. Or the other person might say, actually, I have a lot of hope for that game. I think they'll be good, and maybe they'll upset the star team or whatever. Okay, getting a little too far into the example, I think. But we have this error, this measurement error between people. How are we going to resolve this? Okay, so in order to resolve it, or once we recognize that this is the case, that multiple people can be observing the same thing and come away with different conclusions, we have to say, all right, well, we should do two things. One, we should work and train so that each individual is as objectively as possible, yeah, that's fine, is evaluating the evidence that he or she is receiving as objectively as possible. Second, we need standards and objective standards that can be transferred between parties and can be repeated. So repeatability, replicability is the name of the game. Because if one person watching the football game, let's go back to this football example, I just want to stay with one example for once in my life, instead of stacking example upon example. I know I tend to do that. This football game, you have one person look at the game and come away with one observation, another person with a different observation. Maybe that first person, if they'd watched the game again in a different mood or whatever, and they might come away with a different impression. I've actually, this is really dumb, I know, but I've actually watched a repeat of a game. There was a friend of mine had a video of a championship game that the team that we were rooting for had, and so besides watching the game live, I went ahead and I've watched at least once that recording of the game. I came away with a different impression the second time. Replicability there, just within me myself. I changed my conclusion. I interpreted the data differently, and so much less is that gonna stand from person to person. So we've got reproducibility within the single person. Can one person replicate it within him or herself? Which means we have to that individual has to be disciplined in how he is interpreting the data. And can we replicate it across people? So somebody with a very different background reads the instructions of how I came to this conclusion, examines the same data, and says, you know what, I come to the same conclusion. I see that data, and it makes sense in the same way to me. Now, in the physical sciences, a lot of times that is considered the gold standard, or rather, the physical sciences are considered the gold standard among us social scientists. I'm an accounting researcher, and so I'm mostly based in economics, but we bring in psychology because we're human decision makers making these economic decisions and interpreting the accounting data. And so those are both social sciences. I'm worried. I'm concerned. My research is concerned about how humans are making decisions, entirely cultural and human. And if human beings weren't on the earth, I would have nothing to research. So unlike the physical sciences, which are examining the physical world around us, my example was a social science event. I like that because it's very complex, and it lends itself to the idea of different interpretations, even lack of reproducibility. That is a plague upon social sciences. That's why we look at the physical sciences as the gold standard. And so sometimes thinking about science, it's easiest to think about a chemistry set. It's easiest to think about a lab in which you're doing physics experiments. And so what happens is you record every single thing you do. You record the instrument you're using, you record how old it is, you record the temperature around, well, at least everything that might be relevant. Maybe I shouldn't say every single thing you do, but everything that might possibly be relevant based on your understanding of what you're examining. And you look at the amounts that you've added. You record how long you expose different elements to each other. Let's say we're in a chemistry experiment. You're doing a chemistry experiment. You record the technique you used, including the timing, including the measurements. How many grams of this, how many liters of that, and any ambient circumstances. You record the instruments you were using in terms of the laboratory instruments, the equipment. Okay, and then the idea is you record all that so that those instructions allow somebody in a lab across the world who has never thought the same thing you have thought ever before can do the same experiment and come to the same measurement at the end. So that is a way of getting around measurement error. It introduces the idea of people talking about science, and this is where scientific journals come in, the emphasis on research and publishing. Publishing because, well, if I did something, great, good for me, but there might be measurement error, perhaps I'm just really weird. And so I need to publish it, and so then people around the world can say, that makes sense, and I can reproduce it. I can do the same thing, follow the same procedure or similar procedures. Maybe there's a modification because I'm in the northern hemisphere instead of the southern hemisphere, if it has to do with observing the stars or something like that. I don't know. But I can reproduce it or something very similar and get the same results or very similar results. Okay, so we're trying to overcome measurement bias, measurement error, I should say, in science is what we're doing. We're trying to say, okay, well, we need to have a clear and objectively well-reasoned idea based on our best knowledge of what we have, best theory as far as we've gone so far, and we're going to record it as detailed as we can with every relevant detail we can include, and we're going to communicate it so that the community around can start talking about it and draw conclusions from it or challenge it and improve upon the results. Point out a way in which I messed up the experiment. Point out a way in which my experiment holds but not under certain other circumstances. In improving our theory as we go along. And this is actually strikingly similar to what happens in businesses, because businesses are interested in knowing the reality of their firm. Sometimes, most times, maybe all times, honestly, businesses get off the ground, and once they pass the point of a single hot dog vendor pulling his cart, you start to get magic. It's magic as to how this business works, and no single person usually, once you get past a certain point of size in a business, knows everything about the business and why the magic all comes together. So it really is a wild and woolly world in your own business. And once you've gotten past a certain level of smallness of your business, it's complex, and you get this combinatorial explosion like I talked about in the last lecture, and it just becomes, oh, well, we need to study. Our science is our own business. We are trying to figure out why we make money and when do we make the most money and when do we not. When are we doing things that are irreparably harmful for the community around us, which will harm us in terms of money in the end as well. Those two come together. When are we we need to know what's going on in the reality of our business, and we don't already. And so it's interesting when I look through the idea of budgeting, the idea of testing variances after the budget has been, the period has closed, the idea of making improvements based on those and decisions based on the data that we have from the budget and from the actual results and the variances and so on and so forth. This sounds very scientific to me. We put forth our best guess in the budget, any budgeted number we make or any expectation we present. We then record assiduously the reality, and we put every relevant detail we can think of into the accounting system, and then at the end we look at the variance and we say, well, what did we find? Was our expectation met? Did we come close? Did we get far off? And then we can start to say why. And as we ask those why questions, we build theories and we test them with future budgets and future initiatives to change things. We can start to improve the business over time, and we start to learn more and more knowledgeable about what the magic is that's making this run. And so we have to think scientifically, and I wanted to point out a few specific ways in which we fail to think scientifically, or at least in which some key science-y thoughts. Yeah, I'll go with that. So I want to kind of pick up on the idea of relationships within the data, because that's why we're looking for relationships. We're looking for relationships. That's where we stopped the last lecture, the idea of regression and various forms of regression, to look for relationships within the data set. We're trying to learn this data set. It's a foreign country. It's chaos. We're trying to bring order to it so that we can simplify it enough that we can comprehend it, and or familiarize ourselves with it enough that we can comprehend it. And one of the key things is to get information on the relationships between the different elements of the data. There are some real important things to some pitfalls to avoid, some sciencey thoughts when you're thinking about relationships. I say relationships. I didn't say cause and effect relationships because well, let's use an even more general word that we tend to use in the scientific community, which is association. Strictly speaking, a correlation is only telling you what an association. If A is correlated with B, then it simply says that A is associated with B. It doesn't say A causes B. It could just easily be that B causes A, and so on and so forth. So I might be getting ahead of myself. Let's start by talking about yeah. No, I'm not getting ahead of myself. I see my notes here. Yes. So the perhaps I find a regression and I get this result, and the coefficient is really big, or for whatever the scale we're talking about is big enough that the p-value in my regression result says it's very unlikely that this is 0. There's some relationship between these two, and now I have an estimate of that relationship with the coefficient, and within a certain range of 95% confidence in my regression results. Okay, so I've got all that information. Does that tell me that the dependent variable that I have that coefficient on is causing the independent variable, the y, that I measured on? No, it does not tell me that in and of itself. It tells me they're associated. If I set the regression up the opposite way, I'm going to get almost certainly very similar results. I'm going to see that, actually, it looks like the y that what used to be the y that is now an x is associated with what used to be the x that's now a y. I could flip those two around. The correlation is going to work either way. The two are associated together. And so we start to realize simple analysis like that is not enough. We have to be very careful before we start to assign causation to things. Now, we as humans are not built to do that. It is a tendency, a inborn tendency, and not a bad one. Not a bad one. It's good for our survival that we try to find causes and effects. In fact, that's the name of the game. At the very, very beginning of my textbook, I'm talking about decision making, and I say, look, you want to measure things because you want to know you want to know when you're being profitable and when you're not being profitable, you personally or you as a business, and so that you can get more of the profitability and less of the unprofitability. What is working, let's get more of that. Well, what does that mean? Let's get more of that. It means something is causing that profitability. We want to elevate the cause so we get more of that effect, which is profitability. Something is causing the unprofitability. The cause that's leading to an effect of unprofitability. Okay, well, let's diminish. Whatever the level of that cause is. Is it 1,000 now? Let's bring it down to 500 so we can get less of that unprofitability. So we're doing something like that. That's assuming a cause and effect relationship. I'm assuming if I'm going to try to project my current observations into decisions about the future, I'm assuming that I can control the causes of some future effect. So we are built for reasoning like that, and sometimes we jump, naturally speaking, to conclusions about the cause that we either. There are two problems that I'm going to talk about here. The idea of two general problems. The idea of do we even have data on the cause, or is it in the analysis at least? So perhaps something else is causing it. And third, maybe we have the arrow in the wrong direction. We have an association, but we've assumed incorrectly that the arrow is flowing one direction from A to B. And actually, the arrow flows from B to A, the opposite direction. So my very simple example here is the idea of you walk in, you're in the company, like you don't walk in, you're in the company and you've made this observation. You say, well, all the top performing managers wear these high-end suits. And they are just really nice looking suits. They could be male or female suits. They just look well dressed. Okay, well, it's possible that wearing a high-end suit leads you to perform well. It's possible that's the causality. Those two are associated. That's your observation. The two are associated. It's possible that if somebody gets a high-end suit, the theory would go, you're going to start thinking like a high-end manager. You're dressing for the part you want, for the position you want, which is, I don't want to be a low-end manager. I want to be a high-end manager. I want to be a power manager. So you get a power suit. That's the mentality. That's very theoretically possible. It's also possible to go the other direction. It's possible that when you're a top-performing manager, you get all sorts of accoutrements, you get bonuses, you have more money, you can afford higher-end suits. So more of them are going to have higher-end suits. That's the cause. That's the causal error going the other direction. You have A, high-end suits, B, top managers. So is A causing B, high-end suit causes top manager, or does being a top manager, B, lead to buying suits A? So you have to be very careful about thinking through what is the mechanism. What is the mechanism I'm saying is likely to happen? And if there's any way to gather data on that, to try to find that data. Sometimes you can. Sometimes you can find data about which direction the arrow is facing. Something that would be the key is to get a differential result, to have differential hypotheses. So hey, let's see, what would be the example here? How about new top performing managers? So let's say you would want to, if you were doing this quantitatively, you have some sort of measure of high-end suits. You have surveyed the managers, and they've all told you how much their suit costs, for example. So you have a number. All right, that's A. That's your observation of A across all the managers of the firm. And then you have B, which is their performance. Okay, you've got those two. Well, you're trying to find something that would help explain that would only be a causal mechanism in one direction. Well, in A causes B, the idea that buying a suit leads you to being a top manager, the suggestion would be that the suit precedes top management status. Think through that causal mechanism. That would have to be the case, or at least that would generally be the case. Okay? In B causes A, the suit actually trails after becoming top manager. All right, I'm getting a little too far into this, but I think the analogies, the examples are going to work well because it helps you think about how you would test a causal direction. Okay, well, if I say, all right, well, I'm going to include a C field, in which I say, all right, well, here's what top manager means. It means top fifth, let's say. Top 20% of the manager class here. And I want to see if they're top managers for the first time this month. And I want to see if they already had a suit. So I've introduced this C variable. All right, C, it should be the case. If A causes B, then C should be true. It should be true that the managers who are top performing tend to already have had in prior periods or in this period have bought a power suit. A. If B causes A, then I actually should see the new managers not yet have a power suit, because it will take a while for that top performing status to be translated into bonuses and additional accoutrements, and therefore lead them to having this power suit. All right, so great. I have a way in which I can test, at least I can start down the road of testing which direction this arrow likely faces. All right, so the other idea is, well, we might not even have a C. It might not be possible to measure something. This is the omitted variable problem. It's possible that there is a D which is causing both A and B. So in this example, I'm going to use this example and I'm going to move on because I have a different example too. But I'm just going to keep with the suits for just 1 second. Let's say D is location. And the top performing managers and the power suits are all in a particular quadrant of the United States. That might be it. It might be simply that if you're top performing and you have a power suit, you are from, I don't know, New York City. Let's just say that as an example. I don't know if that's really true. I'm just going to pull out someplace. Let's say you're just from the New York office of the business. Those two are both they're neither one's being caused by the other. They're both being caused by D, which is location. This other variable, an omitted variable in our analysis originally. Okay, so we might not yet have data on this, or might not have included it in observation. So this is a slightly different problem, but overlaps with the previous problem, because to find the causal arrow, which way that causal arrow leads, we often have to introduce previously omitted variables to test it. But we're doing that with the purpose. We're seeking out those variables because we think they're going to tell us the direction. They're a mediating measure here. A would cause C, which would cause B, or B would cause a certain type of C measure, which would cause A, and so on and so forth. So it's now a chain of 3 arrows. In the previous example, the idea of finding causality. Now we're saying, no, we have D, which is on like the top line, and then as a pyramid, it has an arrow down to the left and downward, and an arrow to the right and downward, and it's causing A and B simultaneously. So here we're talking about an omitted variable that causes both of them, and really the two are not connected at all. All right, you have to be sure to have one way to think sciencey about this is to make sure that you have as wide a universe of possible hypotheses as possible. Potential hypotheses as possible. You want to cast the net very wide for what are all the different ideas of why these things could be happening. A lot of the problems we get ourselves into, and I am just biting my tongue to make sure I don't say anything about recent events, but a lot of the bad scientific thinking that goes on is because we, out of course, throw out hypotheses before we ever even allow them to enter the analysis. We say, well, that's not possible. And so we're not even going to pursue that further. I'll just stop there. So make sure you have as many possible hypotheses on the table as possible so that you have as high a likelihood as possible, as high a likelihood as you can of one of those hypotheses being capturing the omitted variable that might be in your analysis. Yeah, the omitted variables can cause different causal mechanisms, or suggest different causal mechanisms, Omitted variables suggest this very different causal structure in which A is not related to B. They also can suggest some boundaries. So let's go to my example that I wrote down about this. So let's just say you have a product that's launching. We're an American company and we're launching a product in Europe. And we are launching in Italy and France simultaneously. To these two countries, the product is launching in those two countries at the same time. It does really well in Italy, but not in France. The question is why? Because you want more of the success you saw in Italy, and you want less of the non-success you saw, the failure in France. So in the future, we want to see more replication of what happened in Italy and less of what happened in France. Either in terms of let's make Italy from good to great, to let's take France from not let's put our product's performance in Italy from good to great, and our product's performance in France from bad to good. We're trying to elevate these. We want to understand. Well, there are a variety of hypotheses here. Let's just say we start with the idea of culture. Our product, it fits the Italian way of life, or it fits the Italian culture in one way or the other. And I'm not going to get into why that would be, because it's a fictitious product I'm just making up, not even going to give a name for it. But the idea is we come to the conclusion, it's just the culture. That the French culture isn't going to like this product, doesn't like this product as much as the Italians do. Well, that is one hypothesis. But let's also consider other hypotheses. Why might a product fail? Well, new product might fail because there's not much discretionary money. Perhaps Italy's going through a growth cycle and France is not. Or France is going through a downward cycle at this particular quarter in which we launched it. Maybe there are other omitted variables from our analysis that we can actually point to. So if we start from thinking and brainstorming, and often this involves discussing, because you want as many people using their five senses and reasoning capacities to think of as many possible ways in which one thing, possible hypotheses for why these things are happening. Sometimes the meetings do produce useful information. You get different perspectives. You get a variety of possible hypotheses. And when you shut down, just again out of course, a particular viewpoint or a particular idea, well, we don't want to hear that idea. It's not playing for the team. We don't like that. You're never going to hear the alternative hypotheses that come from that point of view. That could be a blind spot. That's all I can say. I mean, that's really scientific. That's all I can say. Perhaps it's just some crazy person saying something that doesn't make sense in the end anyway, but perhaps not. You haven't heard. You can't evaluate it. So include as many hypotheses as possible, and then think through how you would test them. Think through what the implications would be for these things. Think through whether or not they're plausible, and how you would rule them out or strengthen the evidence for them or against them. This is one of the reasons why a lot of our analysis, when we get scientific papers, the analysis often involves residuals. They don't care as much in the financial accounting literature when they're talking about financial results of companies and doing regressions on 20,000 companies at a time. They usually are not directly looking at the results. They're looking at the residuals. They say, okay, we have a model of how companies should perform in each of these industries. Our model incorporates the idea of each industry, and it incorporates the idea of of a huge number of factors. Usually these are long lists of variables they've plugged in to rule out other hypotheses of why the results are happening. They're saying, okay, we have some unusual results though. So some of the companies don't fit the model well. They have a big error between what their performance was, either higher or lower, than the line that was being projected by our model. That difference is a residual. And so what we want to do is we want to say, okay, here's our model, here are the results, here are the residuals. And then they go and they mine the residuals for information. That can help you say, well, okay, what do these residuals have in common? What are some possible hypotheses for why these residuals might group a certain way, and so on and so forth. These unexpected results. Unexpected given a prior model. All right, I'm going to move on from omitted variables and that. Let's start talking. Let me enter my last subject here, and that is the idea of endogeneity and self-selection. Let's just talk about self-selection. Don't worry about that big endogeneity word, but let's just talk about self-selections. Your observations are in the wild. They're in nature. They're in the world where people, your business observations are in a social world. People are businesses. Businesses are made up of people, I should say. They're humans making these decisions, and they're not making them in a vacuum. So you always want to make sure that one of your possible hypotheses is self-selection. It is surprising how often it's not considered, and it's surprising how often when it's not considered, it actually is a significant part of the explanation of a result. So there may or may not be handy measures for you to test self-selection as a cause, but let's consider this example right here. You walk in, you're a consultant at a company. You're just your first time here. You read on the flight over the company's new strategy. The CEO has a strategy, and he's said, "Hey, here it is. Here's what we're gonna do." You have some questions. I'm not saying you hate it. I'm not saying it's terrible or obviously wrong, but you have some questions and some ways in which you think it could be improved or that it might be falling short. Same thing, I guess. You walk in to this meeting of all the C-suite executives and a variety of other high-level people in the firm, and you observe that all the other people in the room are voicing their agreement with the CEO's new strategy, even though you have some questions. None of them is expressing your questions or even giving a hint that they would consider your questions pertinent, or would be, not questioning it the same way you are. They're going along with it. You have to consider the possibility that there's some self-selection at play. It is possible that all these C-suite executives and the people high-ranking people in the firm are there in this room because they will agree with the CEO's strategy. They have self-selected or been selected by the system in some way that makes them likely to agree. So you need to take that into consideration when thinking about what does their agreement with this strategy mean. Does it mean the strategy is good? It could. But if there's a self-selection argument, a self-selection explanation for why they might be here, it probably deserves some additional investigation. Or at least it deserves to be a hypothesis that's hanging out around in the back of your head. So as you're going around this company and you're observing how the culture is, you're saying, well, this is the kind of culture that leads to a lot of yes men, that leads to people rising in the ranks quickly because they agree and they kiss a lot of butt. You got to think about what is the case and consider that hypothesis and think about the evidence you see as you go around the company and you get in meetings with the people. Maybe there's a self-selection argument for why they think the strategy is good. All right, I think that's all I have on written down. I'm going to stop here, and thank you very much. Bye.